You can ask an AI what time your flight leaves tomorrow, and it'll tell you correctly. That's worth slowing down on, because the AI genuinely has no idea what day it is. It can't see your calendar, and it can't look anything up on its own. It learned from data up to some cut-off date and was then frozen in place. Its knowledge simply stops there. So, strictly speaking, it has no way to know when your flight is. And yet, it answers. The reason is simple. It didn't know. It found out. Instead of answering from memory, the model reached outside itself. It checked a real, live source, the way you'd glance at your own calendar, and then replied with what it got back. And that's the shift this whole video is about. At some point, the thing that could only write text was given a way to act, to look things up, run real calculations, and take steps out in the world. We gave AI hands, and it changed what AI is actually for. To understand how we let the model out, we first have to be precise about what a language model actually is, and what it isn't. At its core, it does one very specific thing. It takes in text, and it predicts what text should come next, one piece at a time. That's the entire machine. Everything it appears to know is baked into that single act of prediction. And that design leads to three hard limits, three walls of the box. Wall 1, it's frozen in time. A model is built by training it on an enormous amount of text, and that training stops on a particular date. After that, the model is locked. Its internal settings don't change as the world does, so it has no knowledge of anything after its cutoff. Today's news, today's prices, or what day it actually is right now. Wall 2, it can only produce text. Ask it to send an email, and it will write you a perfect email, but it has no way to actually send it. It can describe any action in flawless detail and still not perform a single one. It has, quite literally, no hands. And Wall 3, the surprising one, it's unreliable at things that look easy. Ask it to multiply two large numbers, and it will often hand you a confident, wrong answer. And the reason matters. The model isn't calculating. It's predicting what the answer to a problem like this tends to look like, matching the pattern of arithmetic, not performing it. A pocket calculator from 1975 does this better, because it actually computes the result. So here is what we really have. A genuinely brilliant mind sealed in a room with no windows, no phone, and no calculator. It can reason beautifully about a world it cannot check, cannot touch, and cannot act on. Remarkable, but trapped. The rest of this video is the story of how we opened the door. The solution turns out to be a kind of contract, an agreement between the model and the program that runs it. Let's build it up one step at a time, because once you see the shape of it, everything else falls into place. Step 1. You give the model a list of tools it's allowed to use. Each tool comes with a name, a description of what it does, and the shape of the inputs it expects. Calculator does exact math. Give it two numbers. Search finds current information. Give it a query. Now, the model knows two things: what's available and how to ask for it. Step 2. When you ask a question, the model has a choice. It can answer directly, the way it always has. Or, if it recognizes that the question needs something it doesn't have, instead of writing an answer, it writes a request. A small, structured message that says, "Call this tool," with these inputs. And here's the part people miss. The model cannot run the tool itself. It can only ask. It emits that structured request, and then it stops and waits. Now the program on the outside takes over. Its whole job is to watch for these requests. It reads the model's request, runs the real tool, the actual calculator, the actual search, gets the result, and hands it back to the model as new text. The model reads that result and carries on, now with the true answer in hand. And notice the real shape of what we've built. It's a loop. The model asks. The program runs the tool and reports back. The model continues. And if it needs another tool, it simply asks again. And the loop repeats as many times as needed until the model has everything required to give its final answer. And look at everything that one loop solves at once. The frozen mind can now ask for today's information. The unreliable calculator can now be exact because it isn't guessing anymore. It's asking a real one. The sealed box just grew a door. But there's a catch, and it's an important one. Handing a model a list of tools is not the same as the model knowing when to use one or how to phrase the request. Early on, models were clumsy with exactly this. They'd ignore a tool they obviously needed or format the request so badly that the program couldn't run it. So the real question becomes, how does a model learn good judgment about tools? One of the most elegant answers: let the model teach itself. Here's how it works. Take ordinary text and let the model sprinkle in little experimental tool calls wherever it guesses one might help. Then actually run those calls and check one simple thing. Did having the tool's answer make the model's prediction of the following words better? If yes, keep that example. If it made no difference or made things worse, throw it away. Now repeat that across a mountain of text. From its own filtered practice, the model gradually learns the judgment, which tool, when, and with what inputs. So the model doesn't just receive hands, it learns the instinct for when to use them. And that instinct, that judgment, turns out to be the whole game. Hold on to that, because it comes back at the end. Now the step that's reshaping AI right this minute. One tool call is useful. But the real power appears when the model uses the result of one tool to decide its very next move. Let's watch a real example. Slowly. You say, book me the cheapest flight to Lisbon next Friday. The model thinks, I need the flights first. That's a thought. It calls the search tool. That's an action. A list of flights comes back. That's an observation. It reasons, this one's the cheapest. Another thought. Then it acts again. It calls the booking tool with those details. Think, act, observe, think again. And this pattern isn't something I'm inventing to explain it. It comes straight from the research now widely credited with founding the idea of AI agents, which described precisely this. A model generating, in their words, reasoning traces and task-specific actions in an interleaved manner. That interleaving, reasoning and acting in a loop, reading the result of each step before taking the next, is what we now call an agent. It's the engine underneath the entire wave of AI agents you keep hearing about. And one more piece made this practical. Early on, every tool had to be wired to every model by hand, a different custom connection each time. That doesn't scale. So the field agreed on shared standards, a common way for any tool to describe itself so any model can use it, like a universal plug. Build a tool once and any model that speaks the standard can pick it up. And with that, the chatbot quietly became something closer to a coworker, not just something you talk to, but something you can hand a goal and let it go to work. Step back and notice how big this shift really is. For years, the way you made AI more capable was to make the model itself bigger and smarter, cram more and more into it. Tool use changes that equation. Now the model doesn't have to contain all knowledge or perform every operation itself. It just has to know who to ask and what to reach for. It's the difference between a person who has memorized an encyclopedia and a person who knows how to use a library, a calculator, and a phone. The second person isn't necessarily smarter, but they get far more done because they have reach. And in practice, a modest model with the right tools can outperform a much larger model working alone. And that isn't just a hopeful framing, it's a measured result. The researchers behind one of the first models that taught itself to use tools found that, even next to far larger ones, theirs came out, in their words, often competitive with much larger models. So giving AI hands didn't just add a feature. It changed what we can point AI at, from answering questions about the world to actually doing things in it. Now the honest part, because hands make a model powerful, and they make its mistakes matter far more. There are 3 real weaknesses here, and each one follows directly from how this works. First, judgment. Remember, the model decides when to use a tool, which one, and what to feed it. That decision is itself a prediction, and predictions can be wrong. It can reach for the wrong tool or call the right tool with bad inputs. Second, interpretation. Whatever the tool sends back, the model still has to read and make sense of, and it can misread a result just as confidently as it misreads anything else. And third, the big one, long chains break. Each step in a chain is another chance for a small error, and those errors compound. Picture it. If each step is about 85% reliable, then after 10 steps, the chance that every single step went right has quietly fallen to roughly 1 in 5. String enough steps together, and even small per-step errors snowball into likely failure. This is exactly why the polished agent demos you see often fall apart on real, long, messy tasks. And this isn't a hunch. It's the conclusion of the largest international review of AI yet. Asked whether today's agents can reliably handle long, complex tasks, it answered plainly, for now, that remains infeasible. Not forever, but honestly not yet. And underneath all 3 is a deeper point. A model that can only talk can only be wrong in words. A model that can send emails, move money, or run code can be wrong in actions, out in the real world, where mistakes have consequences. The moment we gave AI hands, the stakes went up. So the real frontier isn't giving AI more tools. We're already good at that. It's giving it the judgment and reliability to use the tools it already has safely and only when it actually should. So here's the whole shift, start to finish. For years, we tried to make the mind inside the box smarter. Then we did something simpler and stranger. We opened the box. We handed it a calculator, a search bar, a way to act, and the thing that could once only describe the world began, carefully, to change it. The model didn't get a higher IQ, it got reach. And that's the quiet revolution hiding underneath all the AI agent noise. AI stopped being something you only talk to and started becoming something that does things for you. The hands are new, and we're still, all of us, learning when to trust them.